Alright, so problem 15. In 1998, a San Diego reproductive clinic reported 42 live births to 157 women under the age of 38 and only 7 live births for 89 clients aged 38 and older. Is there strong evidence of a difference in the effectiveness of the clinic's methods for older women? So we've got to test an appropriate hypothesis, state our conclusion, and if there is a difference, we are going to then do a confidence interval. Okay, so let's see what we come out with. Alright, well, let's take a look at this. So, we're comparing two proportions, right? I'm going to call them younger women and older women, okay? Piece of Y, piece of O. You can do whatever you want. This is the proportion of live births. Let me zoom this out. For younger women, and this is the proportion of live births for older women. Okay, and let's see our hypothesis. Okay, well, the question is, they didn't ask us if it was more effective. They said, is there evidence of a difference? So we're going to do a two-tailed test here. So we're going to do piece of Y equals piece of O. That should be the null hypothesis, H sub O. And then the alternative hypothesis is that piece of Y does not equal piece of O. Okay? So that's going to be a two-tailed test. Okay? Assumptions and conditions. Okay? So we have a random condition. Okay, so it does not state that this is random, so we're going to assume that the sample is representative of all women. Okay, the 10% condition, 157 and 89 are both less than 10% of all women. Okay. Then independent samples. And let's see. The two samples will not influence each other. Okay, and then the success failure condition. Okay, so let's see. NP hat, younger women, let's see, 42 live births, right? So that's greater than 10. And then NQ hats of Y, so that sample was 157. So 157 minus 42 is 115, and that's also greater than 10. And then NP hat for the older women is 7. So that's a problem, okay, because that's not greater than 10. Okay, so that's less than 10, and that's not good. Okay, so and Q hats for the older women, that would be what is it, 82, and that is greater than 10. So what we're going to do here is, really this sample isn't large enough to continue, okay, but what we're going to do here is we're going to proceed with caution. Okay, proceed with caution. Okay, so I'm going to put up caution sign. You know, there is another way to test it using p pooled. So if we find p pooled, and p pooled would be 42 plus 7 divided by let's see, that would be 157 plus 89. So you really have 49 plus so that's 246. So 49 of the 246 is like just about 0.199. Okay, we'll round it to like 0.2. We'll just say that p pool is 0.2. So if you did 0.2 times this sample size of 89 instead, so you did NP pooled, and we did 89 times 0.2, you get like 18. So that's another way of checking it. It's kind of a roundabout way of doing it, but we're going to proceed with this test. Okay, so so we know p pooled, so we're going to name it to say 2-prop hypothesis test, and then we're going to name all the statistics. So n for the youngers is 157, and then p hat for the youngers is 42 out of 157. Let's see, that's 0.268. 0.26, yeah, 0.268. So n for the n hat for the youngers is going to be 1 minus that. That's 0.732. And for the older women, the number of older women is 89. P hat for the older women is going to be 7 out of 89. So that's about 0.08. So this is Q hat, not N. Okay. Q hat for the older women is going to be 0.92. Got it? Alright, so number of younger, P hat for younger, Q hat for the younger, number of older, P hat for the older, Q hat for the older. We already got P pooled, we figured that out. So that's going to be 0.2, so Q pooled, we're going to say is 0.8. Okay, so now we got to do the test. So on top, we're going to do 0.268 minus 0.08 minus 0 over. Why 0? Because we said that there's no difference between Py and P sub 0. And then we're going to do P pooled, Q pooled over N sub younger plus P pooled, Q pooled over N sub older. And then we're going to go to our calculator and we're going to do a two-tailed test. Okay, so let's go to our calculator, stat, test, 2-prop z test. Okay, so x sub 1 is 42 out of 157, and then it was 7 out of, what was it, 89? 89. And we're doing a two-tailed test. We're going to draw that up. And let's see, okay, so, alright, so be careful here. Does everybody see this p-value? Let me zoom that in a little bit. See that? Don't put down a p-value of 4, because there's an e to the negative 4th Okay, so that means you got to move the decimal 4 places to the left. So there's actually 0.0004 is your p-value. Okay, I just wanted to point that out. So we got a z of 3.56. So this is z equals negative 3.56 and z equals positive 3.56 because it's a two-tailed test. Okay. This is where p sub y minus p sub o equals 0. Okay, and our big p value is 0.0004. Okay. Okay, well, we kind of combine these two. So this is NTO. Make decision. Okay, we're going to reject H sub O. Okay, and then state the conclusion, there is strong evidence of a difference in the proportion of live births between women under 38 and 38 and over. Okay, well, what does it look like? It looks like it's more successful. It appears that the proportion is higher for women under 38. Okay, so it looks like this, whatever technique they're using at this clinic, works better for younger women than for older women. Okay, so now we rejected the null, so you got to do the second problem, part of the problem. So we got to do a confidence interval. Okay, so we're going to do panic. Okay, well, the parameters are done. We already did those. We don't got to do those. The assumptions and condition, those are done. We already did those. Okay, we got to name the test. Okay, this is going to be a 2-prop confidence interval. Okay, we got to name all the statistics. Well, we already named all the statistics. They're all right here. Okay, they're all right there. Okay, so we don't have to redo that. So now we got to calculate our interval. So what we're going to do, okay, is we're going to do p hat sub y minus p hat sub o plus or minus. Now we did a two-tailed test, so this is going to be at a 5% significance level, so it's going to be a 95% confidence interval. And then inside, again, we're going to do standard error, so we don't use p-pool. We're going to do p sub y hat q sub y hat over n sub y plus p sub o hat q sub o hat over n sub o. Okay, and that's what your formula is going to look like. So then we're going to go, okay, calculator, let's go to 2-prop confidence interval, 2-prop z-int. Okay, and we got the younger women in first, the older women in second, 95% confidence interval. Alright, so our interval is like about 0.1 to like 0.28. Okay, 0.1 to 0.28. So, what does that mean? We are 95% confident that the proportion of live births for women under 38 is between 10% and 28% higher than the proportion of live births for women 38 and older. So, in conclusion, it looks like this clinic, whatever it is, This reproductive clinic works better for women who are under 38 years old than for women who are 38 or older.